Okay. Hello, everyone. My name is Igo Gvero, and I'm actually coming from Crowgrave here as a product manager to talk to you a little bit about the Clockwork product, which is our static code analyzer. So essentially, you have heard a couple of talks today already from a couple of different vendors, and essentially what I'll try to do is show you a little bit how we work in contrast. The idea behind Clockwork in general is that we've been around for quite a long time, about a decade, perhaps more. We've been recently acquired by Roguewave, and essentially now we're becoming part of their product line. So what I will do for the sake of time, and I know everybody's fairly eager to go to dinner after the next presentation, I'll try to keep it short and hopefully sweet. I have about 12 slides and a couple of demos that I want to show. A few of them are actually fairly important to see. But nonetheless, if you have any questions, feel free to ask me after. But really, you should probably note the email address right now, and I'll come back to it later, and just contact me directly if you need to know about anything else. So the first thing that I have in here as a first slide is it's essentially a description of what is a cost of fixing defects late in the stage of software development lifecycle. And we all know that the later in the cycle that you actually find the problems, the more costly it's going to be. So the idea behind it is that you should find these defects as soon as possible, remedy the vulnerabilities, and make sure that everything is fairly clean before you commit it to your SCMs. So that's something that we're going to talk about shortly. So what are the benefits of using something like Clockwork or a static code analyzer, in this case, our product? Essentially, there's a lot of nice things that you can do to cover security issues, safety problems, and of course, the typical quality problems that you see in the code bases, which are predominantly C and C++ in this case, but we cover different languages as well. So I'll go over that. But essentially, reduce the cost of reliable, secure software by complementing existing testing methodologies as well. So all of you have written unit tests, I hope. And have written different integration tests. So we're not here to replace anything. We're just here to complement what you currently do and hopefully provide you with that feedback fairly instantaneously. The standards that we cover, you can see a bunch of logos that you probably recognize. But essentially, we cover quite a lot of different standards from different applications. So Defense Information System Agency, DISAs, CWEs, Common Weakness and Vulnerabilities, MISRA for automotive industry, OWASP for web applications, DO-178B as well. But in any case, quite a lot of these things are available to you, and you can check against these standards as you're scanning your code base for issues. So what is usually traditionally done with problems like these? There's obviously software development lifecycle here that you see as an arrow. As you're going through different stages in here through the development lifecycle, at the end of the day, if you do the check-in, you perform your some sort of a nightly on-demand build, let's say, you will find an issue and then eventually go back and fix it. And pretty much everyone does that. The problem is that this is quite late in the stage to go ahead and remedy these problems, because they're going to come back to you. You're going to have to redo it, retest it, go through QA. It becomes painful. So timeliness is compromised. The issues are more expensive to fix, even though you're not theoretically in production yet. So what Clockwork tries to do is we try to stop that, as I said initially, immediately, and eliminate these defects from the get-go. So there's no extra work required. There's some in-context checking and fixing. And the important point is that there's continuity of development flow. So we're not disrupting anything as you're coding and as you're saving files, let's say. You're seeing these things either pop up or disappear, and you get this instant feedback of what's going on. So you get essentially straightforward results. This slide in here just shows you a little bit of who some of our clients are and what they've done with Clockwork and how successful it was for them. So essentially, the last 3 bullet points, Lawrence Livermore, they had about 200K savings on a fairly small project, which is fairly important. Harris as well, 60K in 6 months, 10-person pilot project. But something very interesting here is the Lockheed Martin Corporation, one of the groups. They've performed some calculations, and they told us that fixing 1 critical defect per developer in a year So just one issue introduced by a single developer in a whole year, which is nothing, will give you the return on investment. So depending on how severe these problems are and of course, what kind of damage they can do in production, it pays off to have an SCA tool in general, and that's what we're kind of saying here. But anyways, going away from marketing into the actual analysis engine, so what do we do? What is Clockwork? How do we differentiate ourselves? How do we try to stand out, and what are the things that we try to cover? So we currently have hundreds of checkers for these 4 different languages that you see on the board. So C, C++, Java, and C# is what we are trying, what we're currently covering as of this moment. There's numerous standards that are supported. In fact, just talking about MISRA, if you'd like to have additional MISRA compliance, there are literally MISRA checkers that we wrote, which, as of the previous standards that we had, is additional 300 to 400 checkers to an existing bucket of, let's say, 300 for C and C++. So it's quite a lot. It's very customizable, so enabling, disabling checkers, changing severities, categories. In fact, even developing the custom checkers or custom knowledge bases is fairly straightforward. So there's quite a lot of nice things that a developer can use. Now, when it comes to the issues that we discover, these 3 buckets essentially cover those types of problems. So from security point of view, buffer overflows, just to name a few, SQL injections or cross-site scripting if you have web applications that are facing, of course, internet. We will cover those as well. Reliability is honestly the biggest one, so memory leaks, null pointer dereferences, any type of resource handling, all of that is also found here. And lastly, the coding standards and maintainability, all of those standards that I've described, and of course, trying to figure out whether you have dead code, whether you have unused code, unused functions, unreachable code, all of that falls in that category. So it's fairly comprehensive from that point of view. So let's take a quick sneak peek here. I'm going to go through a really short live demo of both sides of what I'm about to talk about next. But what are we trying to do? So first, for reporting, we have a web portal. Essentially, it's an in-house product that you run off of your own servers. And essentially, it'll provide you with the trending capabilities and really nice historical data of how well your project is doing across time. So you'll get a really interactive, dynamic portal where you can analyze these issues and figure out what's going on with your system. So a lot of interesting things in there, drilling through different modules or components, setting up your customized views, assigning ownership to issues, blaming people, changing severities, of course, of certain problems. And the last one is very important, status of issues as well. Triaging or citing of the issues, depending on how they come in versus what you want to do with them, is very important. Because a lot of issues that come in that have a lot of validity, you may decide not to fix at this point in time, and you'd like to defer it for some other release, let's say, because it'd be too risky or dangerous to do at that moment in time. You can cite those issues, you can make different comments about these issues, and essentially collaborate as well. So it's a big collaborative tool as well. So we'll see really briefly what that looks like live. Desktop analysis is something that we pride ourselves with. Essentially, we have coverage for Visual Studio, Eclipse, and IntelliJ IDEA natively. So if you have any one of these 3 different types of IDEs, we will have the plugin for you, which is going to work out of the box directly. If you're using any other type of custom IDEs or different IDEs, or even if you prefer to just type in Notepad or VI or Emacs, you can use something called Clockwork Desktop. And essentially, Clockwork Desktop, what it is it's essentially a tool that's platform independent that runs side by side your editor, whatever that is, and it listens to the code that you're developing, listens to the files, and it provides you with live feedback of what you're doing with it. So essentially, you don't get to edit anything in here. You're simply going to be presented with information, but as you're making these changes, you will see issues appear and disappear. So you still get that instant feedback of what's going on, irrelevant of what you're developing in. So we will, today, I'll show you quickly Eclipse, which is identical to our Clockwork Desktop plugin as well, because we use the same framework. The last thing I want to mention before going into that demo is our continuous integration roadmap. So we have started this beginning of this year. Essentially, what we want to do is we want to follow the developer step by step through their current CI process. So if they're using CI process right now to check the code in, verify obviously how well it's faring, is it breaking the build, isn't it breaking the build, it would be important for an SCA tool to be there each step of the way and let you know that, that what you're doing, in fact, is CI compliant, if I can say it that way. So I do have a brief demo. We'll see if we'll have time for that to give you a preview of what that looks like. But the idea behind it is that it should be something that's very easy to install and set up, automatic deployments, very flexible, and of course, pre or post check-in CI process as well. So what we do right now is as you commit your code, we are able to show you through artifacts in Team City, in this case, what is currently going on with the build. And if you decide to do a test run and not commit, you can do that as well. So quite a lot of interesting things with CI. But anyways, it's a preview. It's what's coming up. And hopefully you will see this early in the next year as well. So I will go quickly into demonstration right now to show you a little bit what that really looks like live. So if I go here into my, I'm not going to expand that fully because I have a couple of VMs. If I go into my Windows VM in this case, what you're looking at right here is an Eclipse plugin that shows Clockwork in action. So what you have on the bottom part of the screen is the list of static problems that we've discovered, what we've reported to you. You can customize, obviously, this and make it as you see it fit. But the idea behind it is that you're going to know what is currently going on with this particular project. And another pretty cool thing is that as you're trying to figure out what the problem is, you are going to be given this traceback. In this case, it's fairly short because it's just a null pointer to reference. But you'll be given a traceback of why we think this is a problem. And it can get fairly extensive depending on what type of problem we're looking at. So some deeply nested memory leaks will have a fairly hefty traceback. So that's one point. The second point is if you make decisions to not deal with certain problems, so let's say I go here to this type of null pointer to reference, I can simply go over to this side, and I can cite this issue as fix in next release and say, worry about this later. And the issue will disappear, and essentially now it's in the system, and you can get back to it if you wish through filtering or different methodology, but you don't need to worry about things that are not pressing. So that's one important point. But let's go back really quickly, again, for the sake of time, to this issue, since we have it on the screen anyways. So a simple null pointer reference. It happens all the time. We've seen it everywhere. So what do we do to remedy this? So the power of the desktop type of solution is that if you want to fix this right now, so if I go here, start typing, and I just want to do a simple null check, so I say something like, if this root, because in this case, null pointer reference says that this root that's returned could be null, is not equal to null, we're going to dereference it and assign it to root string. So all I have to do is here save this particular file, and you will notice that the analysis right now is running in the bottom right corner. So it's something that we call continuous analysis. And as that is running, that issue in here has disappeared. And then, of course, the flow is now changed, and we have to worry about different cases. So the fix itself has just simply fixed this one instance of it, but it's not the right fix. And you're going to know that immediately as well. And then you can go on and do the correct conditional-based verification on this and make sure that everything here is cleaned up. But that's the idea. So it's an instantaneous feedback on what you're doing. And if I was going to go here and accidentally, instead of saying if this root, maybe I say something like root string, because I'm in a rush, I have something to, I have a deadline to meet. I do the same thing. I just did a control S really quickly. And now I'm saying if root string is not equal to null. So of course, I get back the same problem in here that this root could be null. But I also get another issue that says root string could be used uninitialized in this function. So you are going to get these types of messages from whatever it is that you're using on your desktop, one way or another. And that's the idea behind it. I won't go into many more details of the desktop again for the sake of time. I'll show you a little bit of the reporting, and we'll see if we'll have time for the CI, because I know there's another talk right after. But nonetheless, that's kind of what it's about. So going into reporting. So right now, what you're looking at right here, and I'll just go relog in because it probably logged out. What you're looking at here is our web portal, which is essentially our software running off of a server here on the local host using Apache Tomcat, trying to provide some additional feedback on these types of problems. So desktop is very nice. You get immediate gratification. But what happens if you want to follow these issues, if you want to follow trends, history, if you want to calculate metrics, if you want to export certain data, you need some means of actually getting that job done. So web portal, or what we call Clockwork Review in this case, will give you that. So you'll see a list of all the projects that we have, everything we're scanning, and you'll get a nice little preview of how well certain projects are faring, how the issues are calculated, are they dropping, are they increasing, which projects are in trouble. But this is just a small mini preview. The real reporting actually is right here. So here it is. There's quite a lot of different ways of drilling in and getting information that you want to know. So I'm going to just mention a couple here. I'm not going to drill in too much or go into detail. But let's say that you're interested in overall category details. What is it that we do? What is it that we've discovered? And you want one nice big printout of everything. This is one of our verbose reports, textual-based reports, that are simply going to list all types of issues we found, what category they fall in, what checkers have flagged, what is the current number of these issues discovered, percentage breakdown, and of course error density for each bucket of problems. And another fun thing too, or not so fun, is trying to figure out where those problems are. So if you're looking at buffer overflows, you can see that in this case, the getOp.c kind of takes the cake because the issue density is quite high in here and has the most number of issues. So all of that is, of course, presented. Since I'm already on this report, really quickly scrolling down all the way to, let's say, here, you will notice some of the coding standards. So if you enable taxonomies to verify coding guidelines, you're going to see that in this report as well, and honestly, everywhere else in reporting. So if you're trying to abide to some of these rules, you can see what is currently going on there. So category details, just very verbose, detailed report. Citation, as I mentioned initially, if you want to see who is citing issues, who's triaging, that's here too. Fixing activities by module, what has been corrected and where. Couple of interesting ones here are these. I'll just go through 2 or 3 of these. Issues by state. This is how you know that over time you are perhaps doing a good job or maybe not so much. If you see that the overall bars are dropping, that the issues are getting fixed, you're on a good path. But if you see that this is increasing over time, then obviously people are introducing more issues and there's something to be hopefully done. So this is something that obviously managers like to look at all the time. Drill down, if you want to see open issues by module, you can go through, you can simply go click through and see where these issues occur. And you can get different representations, of course, of pie charts or bar graph or whatever different type of visualization that you like. So a lot of interesting things here. Metrics, projects, project configuration, if you want a quick summary of the files, scan, densities, versions, different builds that you have enabled in here. All of that is present here. So again, for the sake of time, I won't say much more. I'll just jump into configuration and show you here. Maybe I can do it this way so you can see it better. That these types of taxonomies and standards are part of the project, and this is where you can enable or disable these. And of course, apply it to filtering as well. So all of that is in here too. So for the one last thing, from the CI perspective, just going back to a different VM here to show you the integration. What I have here briefly is IntelliJ IDEA. It has Clockwork plugin in here as well, and it works in a really similar fashion. It reports on the number of issues that you have, where they are, provides you with traceback, same story. The important difference in here is that you also have, you have an integration with TeamCity in this case. So what happens if there's certain things that you have done in here, there's a small diff, things were removed, and now there is changes. So now as a developer, you can right-click here, say commit these changes. I would like to go ahead and perhaps commit this. Now, if I go here, what I can do, one important point that I can do is simply perform a remote run, essentially a test run. Let's see if this actually passes before I commit it. So I don't want to commit. I click on submit, and I don't want to review anything. I'm simply going to run it in TeamCity. So here I'm in TeamCity, and you'll see immediately that this particular CI build is currently running. And it's running clockwork analysis as well. It's trying to look if there's any particular types of problems that are introduced or not. And you will see shortly after in here, this will disappear. So you don't really get anything back. The numbers are incremented, but you don't get that new build. And if I go back here to my IntelliJ IDEA, it will tell me that the build was successful. Everything is looking good. So if I do the exact same thing and make it quicker right now and actually do the commit, so again, the idea is the same. There's no differences right now in SCM. There's no diff. Everything is checked in. I go back here. It's the same story. Now we have a build 14 because we had a couple of test runs before, 12 and 13, that weren't registered. Build 14 is now running, and it's actually going to be safe kept here, and here we are. Report is one mutual problem, but the important point in here are artifacts. And if I go here to artifacts, to our clockwork results, we're going to, let's go log in here. We are going to see now our code review tool called Cahoots reporting on what has changed since the last time. How many new issues, how many fixed issues, and revisions in build. My diff in this case ended up removing some code and removing an actual problem, and therefore the issue is decremented, so fixed issue is 1. But you will get that in here. And if I go and look at this diff, you will notice that I have in fact had a null pointer dereference of sort in this code, and I've removed this print point to method, and therefore I removed that problem altogether, and now we are good. This is now fixed. It's just a small, simple overview. In any case, just to conclude everything for today, I'll go back to slides right now for summary. Let's go full screen, and just reiterate a couple of things that I mentioned. So modern source code analysis is what Clockwork will provide to you. It's definitely a point of greatest time saving for developers, especially if they're doing this at the desktop and getting these types of results immediately. Lowest cost, of course, preventing quality security issues, detecting these issues at their root as they're being introduced, and of course, a lot of nice reporting capabilities. Now, mitigating the issues is going to consist of trying to focus on a problem, ignore it or fix it, and of course, rinse and repeat, or in some case with continuous integration as well, you can use it as part of the developer workflow and see how's that faring with the overall CI builds. So adapting SCA into your CI process is something we're striving to do, hopefully shortly. I think that would be it for now. Thank you very much.